All right, so today we are starting a new section. The new section is 7.1. We're going to start today by classifying polynomials. So we'll go through this first box of definitions to start, where it says finding the degree of monomials. Today is kind of vocab heavy, but we'll get through it. I'll wait for the airtime to load. Retry. So a monomial is a number, variable, or the product of a number and one or more variables with a whole number exponent. So that's a long definition. So if you want to underline it, so you have it there, because we're going to be using that as we go through. We'll talk about mono. If you have mono, like, you know, in movies, they wear like the one little like eyeglass. That's called a monocle, meaning it covers one of your eyes. If you speak in a monotone voice, you only speak at one level. If monogamy is you're married to one person, so mono means one. Nomials is talking about number of terms. So monomial means one term. So with monomials, we can have what's called a degree of a monomial. And the degree of a monomial is the sum of its exponents. So this piece is going to be important that it's the sum of the exponents, because when we talk about what's called a polynomial, that's going to change. But for monomials, to find the degree, you take the sum of the exponents. So we can have degrees anywhere from 0 to as high as you could think of. Right? If we have a constant term, so meaning just a number, that does not have, that's degree 0. All right, it's the 0th degree. So in this chart, we can fill in. We'll start by checking these monomials and telling them what degree they are. So 10 is a constant. 10 is 10. 10 never changes. So 10 has degree 0. If we look at 3x, this is 3x, and then we always have above our variables to the power of 1. So we call this, if we take the sum of our exponents, this would be a first degree monomial, or we just call it degree 1. You'll hear me say both. You'll hear me say first degree or just like degree 1. I like first degree better. Next one. Again, this is a monomial because we only have multiplication happening between here. We have a number and variables being multiplied together. So it's a monomial. It's one term. Think of all of this comes in a package together. It's one term. So to find the degree of a monomial, we have to add all of our exponents. We see that this is b squared, but this a is to the power of 1. We kind of got practice putting those to the power of 1 on there when we were doing our exponent rules. So this is a degree 3 monomial. And then our last one, since it's z to the power of 5, this we would call is a 5th degree monomial. It's to the power of 5. In the other column to the side, we're now going to give reasons as to why this column where it says not a monomial are not monomials. So for our first example, we have 5 plus x. This is not a monomial because we have addition. If you have a monomial, your terms or your numbers and your variables are only being multiplied together. So the reason this is not a monomial is because it has addition. 2 divided by n is not a monomial because we have a variable in our denominator. So variable in denominator. Right. Next example, 4 to the power of x. Well, let's go back. This is, again, another reason you could say, because if you write something as a fraction, the operation that's really happening is division. And for something to be a monomial, we only can be multiplying our terms together. So you can't be doing any dividing. So that's another reason why you could say, no, this is not a monomial. 4 to the power of x is not a monomial because we have a variable in the exponent spot. So variable, we could say variable as a power ruins it for us. It's not a monomial. All right. And the last one, x to the negative first. Why this is not a monomial. If you remember your exponent terms, to make an exponent positive, we can write it as 1 over x. And again, we have a variable in our denominator. We're dividing now, so this is kind of the same reason as our 2 over n example. Because we have a variable in our denominator, so that's not a monomial. So on the rest of the front of the page, I just gave us 8 examples of monomials, and we're going to figure out the degree of them. So for example, 1a, we have 5x squared. We're taking the sum of our powers. So this would be 2. That's our only power. We just have x to the power of 2. For this next example, we have negative 1/2 x times y to the third. You may think, oh, this is a third degree, but remember we have to sum our powers. There's a 1 right here. So this is to the 4th power. Or it's the, sorry, not to the 4th power, it's the 4th degree. Example C, we have to add sum our exponents. So 3 plus 3 is 6. So it's a 6th degree monomial. ABC, let's do D now. A constant, negative 3 is a constant. Negative 3 never changes. It's always negative 3. So 0. All right. For f, what's my degree of f? 4. I can zoom out. Oh, I didn't do E. What's my degree of E? 1. My degree of G, we had to add our powers together. Yep, because we have a 1 here, a 3, and a 2. So this is 6. And the next one is 9, because we have a plus 1. Degree 9. Because I add all of my tiny numbers together and I get 6.
I know. Sure. Yeah. I know.
All right, so that's one piece, find degree with monomials. The key you have to remember, when we're doing monomials, you are summing. All right, let's bring the chatter. Shh, bring it back down. I know you're all super excited about degrees. When we're going to do polynomials on the back now, which are going to be slightly different when we're trying to find the degree of a polynomial. So flip to the back side. And this, on the top, it should say find the degree of polynomials. I forgot to change it. Poly.
Is this when you were making it?
This morning, yeah. So the prefix, so the beginning of the word, poly means many. So have you ever heard of a polygon? That means a many-sided shape. If you're polymorphic, that means you can change. So like water is polymorphic because it can change into ice and it can change into steam. If you're polyamorous, that means you love a lot of people. So poly means many. So polynomial means many terms. So a polynomial is made up of a bunch of monomials together. Each monomial is called a term. So you may have heard me say that before, like first term, second term, or if I'm helping with your homework, you have to add these two terms together. That's what I'm meaning. It's just like two pieces of your expression. And then we have specific names. If we have a polynomial that just has two terms, it is a binomial. If we have a polynomial that has three terms, it is a trinomial. And with polynomials, our terms can only be added or subtracted from each other. So for example, this binomial, it's called a binomial because it has two terms. First term, second term. And if you look at each of these individually, this 5x is a monomial. 2 is a monomial on its own. So when we put two monomials together, we get a binomial. Looking at the trinomial, now we have three terms. Tri for like tricycle, triangle meaning 3. X squared is a monomial by itself. 5x is a monomial by itself. 2 is a monomial by itself. But when we take it all together, we get a polynomial. And then if you kind of want to be more specific, you could say a trinomial. To find the degree of a polynomial, you don't sum them, you take the greatest degree of its terms. So that's the important part. You take the greatest degree. So this binomial, 5x plus 2, the greatest degree is this 5x. This is to the power of 1. So this is a first degree binomial. This trinomial, it's not a third degree. You don't want to add 2 and 1. You just take the largest exponent, or your largest tiny number, your largest power. So this is a second degree trinomial. When we're writing polynomials, we'll have something that's called standard form, and I'll show an example of that. But standard forms is just writing it so as you're reading it from left to right, your exponents or your powers are decreasing as you go down. Think of it as, instead of standard form, think of it as like standing form. Like if I was to line you all up in terms of height, your heights would decrease. We're going from, if I put the tallest person at the left of the room and the shortest person at the right of the room, we'd be decreasing in height. That's how we do it in standard form too. Our powers decrease. And then we have what's called a leading coefficient, which is our first number that we see. So I'm going to give you an example of just a polynomial, and then we'll rewrite it into standard form. So let's say you had something like 17 plus x to the 4th plus x squared plus 3. To me, it doesn't look nice. It's kind of disorganized. It looks a little bit because we have a power of 4 and a power of 2 to the middle. We can write this in a nice way, which is what we call standard form. So over here, we'll put it in standard form, where we put our largest power first. So our largest one is x to the 4th, so that goes first. Our second largest is x squared, so we put that next. And then go back, put a 3, put an x next to the 3. So then we can make our next term, we can see it. Because this is to the power of 1. So we're still decreasing. And then you always put your constant in the back. So plus 17. This is standard form. Mathematically, they mean the same thing. But we have to do it this way. And I'll tell you why. You may be like, oh, Mr. Scully, you're being so nitpicky. Like, I like it like this. If mathematicians didn't develop this kind of standard form, none of the formulas would work. Everyone would be doing things differently. If we have a standard form, it sets us up that we can all be doing the same thing, and it can all look the same. It would be like standards, like meaning always the same. So like, for example, the standard on Wednesday at Two Rivers is that we always have warrior time. If we just decided like willy-nilly, oh, we're going to have warrior time this Wednesday. Oh, we're not going to have warrior time this Wednesday. Everyone would be doing different things. It would be super disjointed. But since we have a standard, everyone's on the same page. So that's what standard form just puts everyone on the same page when they're writing things. This is going to be super important as we move forward through this unit. Because we'll be doing what's called factoring. And to factor correctly, you have to be in standard form for kind of our process to work. So we're going to have some practice doing that now. With example 2, you got to make another correction for me. You got to put a x next to this 15. That's the last correction you got to make. We're going to write this in standard form to start. So, taking this to put in standard form, I have to put my largest power first. Well, my largest power is to the power of 3. So I have to put x to the third first, but I have to take the operator that's in front of it to preserve kind of our integrity of our math. So our first term would be minus x to the third. Our next term, our next largest power is as 15x to the first. So you can write plus 15x. Then our last term is a positive 3. So you go plus 3. This is standard form. So standard form, and the degree is 3. Because if we're in standard form, your degree will always be with your first term. So minus x to the third is our first term in standard form, so it has to have a degree of 3. And then when we say leading coefficient, we have to think of the first number that we see. What number goes before this x? 1. So that's our leading coefficient. It always is with your first term, the number that is in front of the variable. Excuse me. So we have our leading coefficient is -1. All right. So let's do these last 3 examples. We're going to write them in standard form. Identify the degree. Classify each polynomial by the number of terms. So this would be a degree 4 because we have z to the 4th, so our degree is 4. It's already in standard form just because it's a monomial. All right, we only really deal with standard form when we're talking about polynomials. All right, so sometimes on the homework, if it asks you to rewrite it in standard form, it already may be in standard form. You don't have to change anything. Just know that. But example B, we do have to put into standard form. Because we have 4 plus 5x squared minus x. My largest power goes first, so 5x squared. I put, this is x to the first, so that has to go next. minus x. And then my constant term will always be the kind of the caboose of the polynomial. So plus 4. I then take my degree. This is a second degree polynomial. My leading coefficient would be 5. And this is when it says to classify, it means tell me if it's a trinomial, a binomial, a monomial, things like that. Yeah. Nope, when it's a monomial, you do not add them. You just take the largest one. If it's a monomial, then you add them together. All right. Last one, to put this in standard form, we have to put q to the 5th first because that's our largest power. It's larger than q to the 1st. So this is degree 5th degree, degree 5. And this would be a binomial because we have 2 terms. Bi meaning 2, nomial, number of terms.